Good morning, good afternoon, and good evening, whatever time zone you may happen to be in. Welcome to the Spring Webinar Program. My name is Peter Humphrey, as always, your MC. I am lucky enough today to be joined by one of the newer members on the Spring team, former Netflix open source engineer from the Engineering Tools Group, John Schneider. If you were at Spring One Platform last year, you might have caught him on main stage. If you weren't, you can see a short 15-20 minute video of him presenting at Spring One Keynote last year on our YouTube channel, which is pretty cool, his debut appearance. So John, maybe would you introduce yourself, tell the audience a little bit about who you are, what you work on at Pivotal, and then we'll get started with the webinar content.
Sure thing. Thanks, Peter. Thanks for the introduction. Again, my name's John. I'm a member of the Spring Cloud team here at Pivotal. I joined Spring of last, and I set about immediately working on a new project. It's called Project Micrometer, and this is the new dimensional metrics collection facade that underpins Spring Boot 2's application metric. There's a lot to unpack there. We, in Spring Boot 1.5 and earlier, we had a very unsophisticated mechanism for metrics that just allows you to define counters and gauges in a hierarchical way. And what we were seeing as we came to the first major release of Boot really since its beginning, the Spring Boot 2 release, is that there's a new wave of monitoring systems out there, both SaaS's like Wavefront and Datadog, SignalFX, New Relics, New Insights APIs, and so forth. And then there's also gaining popularity our open source offerings in the dimensional metric space like Prometheus and Netflix's Atlas and Elastic. So we wanted to, in typical Spring fashion, we wanted to provide a single SPI that you can interact with for your metrics and keep your interaction with those metrics separate from vendor-specific code. And to that end, we created Project Micrometer. The tagline we like to say it's like SLF4J, but for metrics. That's kind of how to view it.
So many people resonate. So many people resonate with that, John. It's great. I think one of the questions I know I had right up front was, could you just define multi-dimensional metrics as opposed to like logging or other types of metrics that get out there? I know that was a frequently sort of asked question. Like, what does that mean exactly? Just before you dive in more detail.
Yeah. I think we're going to have to see it by example, really, to get a notion of what dimensionality brings us. But as far as logging goes, there's three pillars of observability, as Adrian Cole likes to say. There's logging, which we all know and love. You kind of emit a line per event. And there's tracing, distributed tracing systems like Zipkin, Spring Cloud Sleuth, Jaeger, et cetera. And those allow you to get an idea of the contribution of latencies across a single request. And then there's metrics. And metrics data tells you about the performance of your system in the aggregate. It'll say that, say, for the last minute, service A had an observed throughput of 100,000 requests, and service B's observed throughput was 60,000 requests. And if you just look at logs, of course, you just see potentially a log entry for each one of those things, but it's hard to reason about the change in rate over time or the performance of the system over time. And that's what metrics brings you. So with no further ado, I'll get into just the basic constructs, and then so we'll do this first. We'll kind of introduce the SPI that Micrometer provides to you, and then we'll shift over to a Spring Boot application that has some metrics already collected automatically for you, and work out how we can visualize those using the example of a Grafana dashboard pointing at Prometheus. So just to start out with, we just have a simple main method here. And the first construct that you really interact with is just a meter registry. And a meter registry is both the holder of metrics that are going to be published and also the mechanism by which you create them. So if we wanted to create, for example, a counter, we can create a counter called my.counter here. And there's a specific counter type. And we can interact with it. We can increment it over time, or we can increment it by a fixed amount, those kind of things. The timer interface is just different. You know, it's registered in a similar way to the registry. But, you know, rather than having an increment method on it, there's record methods. So you could say, I want to record that I know that this particular thing took 100 milliseconds. But more commonly, you would use something like one of these, where you would just wrap a block of code in this timer, and Micrometer would deal with the calculation of the amount of time that took for you. Now, there's a number of different types, and so we have gauges as well. There's some more less commonly used ones deep down into this more interface where you can do things like long task timers and time gauges, which aren't very common, and function counters and things like that. But we'll focus on these two for now. We mentioned that Micrometer was dimensional. Whenever you create a new metric, you can add tags to it. So I may say that this my.counter is coming from app foo, and you know, perhaps I have a second counter here who comes from app bar. And when I look at those in a dimensional monitoring system, the typical pattern, the query pattern, is you just look at my counter. And you know, depending on the back end, it'll do one of two things. It'll either show you 2 lines for my counter, or show you one for foo and one for bar, or it'll roll them up into one line. And so you would see that if I'm just looking at my counter, in this particular period, there were 10 increments to that aggregate. And you could then dimensionally drill down and say, actually, I just want to see the contribution of foo to this particular counter. So a common thing to think about is that Spring Boot automatically collects for you is HTTP server request latencies and throughputs. So you could look at HTTP server request latency across the dimensions of all of your API endpoints, their various URIs, across all your apps, across all the regions that you've got those apps deployed in, foundations, et cetera. And you could come up with a, average latency, let's say, for all API endpoints across your organization. That isn't really super useful, but you could take that single metric then and start drilling down and say, what's the latency of, my API endpoint in US East 1 versus US West 1, or what's the latency of this app versus this app, or this URI endpoint versus this, and kind of drill down arbitrarily along those lines. That's pretty neat. The other thing to note is that in Micrometer, you're always interacting with a single meter type, and so the type of this is a counter and the type of this is a timer. But depending on the meter type, it could actually present multiple things to the monitoring system. In the case of a timer, it's always going to present a count. So you would get a notion of the throughput of the number of times recording was happening. It's also going to present something like a total or a sum, which is the sum of all the latency that's exhibited over an interval. Depending on the system, it's always going to demonstrate or present a decaying max latency. Some of them will present an average. It depends on the monitoring system. Sometimes we'll ship percentiles. So a lot of things can come out of just this one interaction you have with a particular meter. The next thing to note is, when we're thinking about meter registry, there's a special kind called a composite meter registry, and a composite allows you to shift, metrics to multiple backends. So I could say, new JMX meter registry. I want to use the default system clock here. I could also say I want to ship to Prometheus. And so now when I interact with registry, whenever I create a counter off this registry, that same data is exposed and presented in both of those systems. A few other things I want to make mention of while we're here is that, well, let's first think about how my counter would be represented in a hierarchical system. So we've mentioned that micrometer is a dimensional system. How would this be presented in a hierarchical system? Typically, you would do something like this. You would have my.counter, and you would start adding tag key value pairs, conceptually anyway, to the end of the name, and come up with this name taxonomy like this. And so you may have a counter.app.bar as well. And so maybe, this equals 5 right now, and this equals 5. And if I want to, in a hierarchical monitoring system like Graphite, if I want to understand the total count, I might do something like this, and I might wildcard it and say, well, there were 10 of those. But this kind of system is fraught, and this is why we're seeing most of the new offerings moving away from this, because suppose I go and add now. I go and add a host to this. Well, now where do I put that? It gets difficult. What if I put it here in the name? If I try to embed it in the name like that, suddenly I've broken this query that I was reliant on. The order matters, and of course I could go everywhere my counter exists in my code anywhere and add this host tag, and then I would be able to to come up with a host.h or host.star or something like that and fix the metric. But while I'm rolling out all my infrastructure, I've lost visibility now on this particular metric. So in a dimensional monitoring system, it's just stored differently. It's really the same data. I'm just going to represent it this way. You might say app foo, and there may be another one, app equals bar, host equals h. And the selection, would look, something like select my.counter where, app equals foo, or, where, app equals star, or starts with, f or something like that. And notice that in this case, because of the way the data is stored, this doesn't break when I just arbitrarily start adding more tags here. And so it's just more of a mechanism how it's created. Now, Micrometer does support hierarchical systems like Graphite or Ganglia or JMX, but it's much easier to take a dimensional name like this, my counter with tags, and generate a hierarchical name. I can take this and I can just like we've done here, I can take those tags and I can append them in a dot-separated way to the end of that name. That's fairly easy to do. When you interact with a metrics library like Dropwizard 4, it's very difficult to go from a hierarchical name to a dimensional name because I have to make some assumptions about the structure of the name. If I want to say, look for dot separation that indicate new tag key and value pairs, the basic form of that breaks when I have a dot in the name. So it's very difficult to do in a general way. So yeah, Micrometer, when you're going to a hierarchical system, it uses something called the hierarchical name mapper. And this is a configurable thing for each of those hierarchical implementations we support. We just define basically an interface that tells me how to take a dimensional name and transform it and flatten it into a hierarchical name. And because we have a composite, what I hope we'll see is that folks will move. Over time, maybe they rely heavily on Graphite right now. Go ahead and add the Graphite registry, and also as you start to transition to a newer monitoring system, add that as well, and for a time ship it to both places until you can move your infrastructure. So it allows for you to gradually move rather than having to just kind of do it all at once. There's a few other things to note about, I already mentioned the hierarchical name mapper, but one thing that really distinguishes Micrometer is its notion of normalization. And Micrometer normalizes these metrics to the backends, the individual backends in different ways. So, in the code, I've defined my.counter right here. But, that name, my.counter, it may look like my.counter in SignalFX, where we like that dot separation because the SignalFX UI allows you to explore metric taxonomy by collapsing or expanding these dot separators. But if I did the same thing in Elastic, for example, I had my counter and I also had just my, this breaks Elastic, because Elastic is going to build an index. Well, suppose I did it the other way around. I did my and then I did my counter. It's going to build an index for my initially that assumes that, that there's nothing underneath it. So that would be bad for Elastic. So there's not really one. In Elastic, I'm going to take this name, my counter, and I'm going to transform it into something like this. I'm going to use camel case notation instead, which works for Elastic. And in Prometheus, my counter may look like snake case like this. But in Prometheus, the convention is whenever you have a counter, you do something like you also append total to it. So you don't have to, put total up here in the name. That's maybe idiomatic in Prometheus and not in another monitoring system. Micrometer already has built-in notions of the naming convention that's used for each implementation and transforms it for you. In some cases, it's just an idiomatic concern, and like I mentioned here with Elastic, in some cases, it's actually a breaking consideration. So I think this is unique. As far as I know, with DropWizard 5, which is also becoming a dimensional collector, there's no such notion of naming convention normalization. And Google's offering in Open Census also doesn't have any notion of that. And I think it's more important than appears at the beginning. Similarly, when you interact with a timer, suppose I said of seconds 1 here in Prometheus, I should display this as 1. But in Datadog, I should probably display as 1,000 milliseconds. The actual base unit of time convention is different in each monitoring system. And so, Micrometer is aware of that, and it'll scale time dimension, or time values, to the appropriate scale for your monitoring system. So I don't have to know that I need to take my timer and multiply it times 1,000 here because I'm interacting with Datadog. I just record whatever the true value is, and Micrometer will deal with the scaling to the back end for you on your behalf. Those are just a couple of the things that we do for you. And then lastly, I guess, the exposition of a timer is different depending on the back end. So when we ship to Datadog, we'll ship a count, a sum, an average, and a max. But when we ship to something like Atlas, we're just going to ship counts, we're going to ship total time, we're going to ship max. So it actually looks different. The structure of the data looks different depending on the back end. And that's one thing I think, Micrometer is doing a little bit differently. We're focusing on the user-facing SPI, which is when I'm interacting with a timer, I deal with, I want to record it or I want to increment it. There's no proto, for example. There's no proto that defines the structure of a timer across these monitoring systems. That can't work. They're very different from one to another. So I think that's enough about the just introduction to the SPI. Let's do some fun stuff. Let's look at Spring. Spring, like I mentioned, has now included Micrometer out of the box in Spring Boot 2. If we go to start.spring.io, I think Josh Wong's favorite landing page, we can generate a project, and we could say, we're going to take a reactive web and actuator. Really, actuator is what auto-configures metrics in Spring Boot 2. But it doesn't do it by default. It's, Micrometer and metrics in general is still an optional dependency in Spring Boot 2. So if I used the project generator, I would have come up with something that had these two dependencies in it. I would have had Spring Boot Starter Actuator and Spring Boot Starter WebFlux. And to add registry implementations, I just have to start adding these dependencies. So in this case, I want to export metrics to both Prometheus and JMX. And if I configure, or if I add both of those items to the class path, Spring will auto-configure them and ship metrics to both. When we look at the actual application, there's no annotation or anything that indicates that metrics is happening. It's strictly keyed off of the presence of those items in the class path. Over in application properties, since we're working with Prometheus specifically, Prometheus is unique amongst monitoring systems in that it pulls metrics from individual instances. So a Prometheus server will actually query an endpoint in your application to retrieve the metric. Every other monitoring system that we support right now is push-based. In other words, the application itself performs a request against the monitoring system to deliver those metrics on a regular interval. So for Prometheus specifically, Spring Boot auto-configures an actuator endpoint called Prometheus that just looks like this, and this format is peculiar to Prometheus. We know how to expose the data in a way that Prometheus expects it to appear. So, there's also a actuator metrics endpoint, just like there used to be, but it's a little different than it used to be because we're dealing with dimensional metrics right now. It's hard to represent them all in one payload, so you have to kind of drill down or CPU.count. I think that's one of them. Nope, wrong one. We'll say JVM memory used. And you get a notion of what tags are available, like the area and heap and so forth. Really, this actuator endpoint in Spring Boot 2 is more of a diagnostic tool than it is something that's intended to be used to feed a monitoring system. Micrometer is providing implementations that know exactly how to expose metrics to each of the supported monitoring systems. And this is just kind of something on the side to look at as well. So I've done a little legwork here already in this application. If you want to see more about Spring Boot 2's introduction of WebFlux and the reactive web, I highly suggest Bill Webb's webinar on that subject a few weeks ago. But we've kind of preloaded that. We've created a person in a repository and a controller that allows us to retrieve those persons. We've created we're going to use Mongo, embedded Mongo here. We've loaded up a bunch of people from the U.S. Census Bureau's records from 1990, and we're going to just kind of start out with that. Also, in the repository that goes along with this webinar, there's a scripts folder, and inside of the scripts folder, you'll find that instructions for how to replicate this setup. You can run Prometheus and Grafana locally yourself. If you're on Mac, you need to configure a loopback alias like this because of limitations in the Docker runtime on Mac. And then you can simply start Prometheus and start Grafana with start scripts. We've also provided a Grafana dashboard for you. And when you run Grafana.sh, it will launch the Grafana Docker container and automatically add the Prometheus data source and that dashboard to that Grafana instance. So you just have it running for you. And then lastly, we've provided just a load script that uses Apache Bench to just exercise our /persons endpoint here, so we can see some cool things coming out of our dashboard. So let's take a look at that. Then we're gonna go to the terminal here, and we're gonna start running that load script. So it loads down that endpoint. And while it's doing that, we're gonna come over here to Grafana and we're gonna create a new dashboard. And it starts out like this. We're gonna edit it. And let's just start with JVM memory as the first thing that we do. We're going to select the Prometheus data source. And notice, this is the auto-configured metrics in Spring Boot. This name would have appeared as jvm.memory.use.bytes, or rather just memory.use in the actual instrumentation code. But it was ran through the Prometheus naming convention. And the Prometheus naming convention in this case is to create a snake case name and appends a base unit to the end of that name. So again, we're kind of making it look idiomatic in the language or in the monitoring system that we're using. And if we do that, what we see already is that there's several. There's already some dimensionality to this. There's JVM memory used in application webinar. And so if we have multiple applications running, there may be several of these. But it's also divided along the heap, or the portion of the heap that it's measuring. So let's make this look a little bit prettier. I like to remove the fill. I think it's a little bit too much. Let's thicken up the lines a little bit so we can see them a little bit better. And it's typical with JVM heap to present them as a stack diagram, so we'll do that. And then notice over here, it kind of says 200 mil, 300 mil, 400 mil, etc. In Grafana, we can go over to the axes and define a unit, and we'll say this unit is in bytes. And when we do that, Grafana knows now how to present the Y scale to you. It knows, oh, okay, I'm dealing with bytes, and so if it exceeds a certain value, I'm going to display it in megabytes or gigabytes or whatever it may be. So that's really nice. We can also apply a legend. So, notice this is kind of the full name here, but we've got tags inside of it that really are the things that distinguish each of these lines. So here I can just select a tag, like ID. And now this looks a lot better. Now I see, the green line represents the easy space, the yellow line represents old gen, etc. down the line. So that's cool. Notice I'm consuming more memory. I just, that load test is running, and it's hurting. Let's do another one. Let's do JVM GC events. We'll go over here to the same deal here. Now this is interesting because we've got GC pause. We can just look at the throughput of JVM pauses. We'll start that way. And in Prometheus expects cumulative count. So you'll see there's been, since the beginning of time, there's been already 2,000 minor collections that have been done on this application. But I could also look at the rate at which those things are happening. So, there's roughly 4 minor collections happening per minute here. And I could also look at, since we've got more metrics on this, I could look at JVM GC pause sum. And now this is the total sum of all GC metrics that are, or GC pauses, that's the latency of each GC pause in this interval. I'll say I can look at that over 1 minute. So if I take the total latency and divide it by the count, I get a notion of the latency of each GC pause. So we're seeing here that, each minor collection is taking around 5 to 6 milliseconds. That's kind of interesting. We're going to add another one here. We could look at GC pause seconds max and see that actually, the worst case scenario for a GC event, for example, in this max GC, it took, roughly 150 milliseconds. And this is one thing I want to point out. You saw that we were looking at average down here, and the average was super low, wasn't it? It was like 4 or 5 milliseconds per. The max is substantially higher, isn't it? And so max is often something you want to view when you're looking at timers. We're going to remove this guy for now, and we're going to go back to just looking at the throughput as well.
John, real quick, I just want to say a few questions have come in. Folks,
Sure.
just want to let everyone know that the session is in fact being recorded and it will be shared. It's available within usually a few minutes of the close of the webinar. And then also there is a GitHub link John is very carefully prepared for everyone. So that is also in the attachments and links section, and there'll be a link to it at the end of the webinar. So don't worry, all these materials are available for you. John, sorry to interrupt. Please go ahead.
No. All right, sure. Yeah. I mean, it gave me a chance to really make this pretty, which was great. I feel like Bob Rock here, just like painting little trees, just adding little charts here. That's what I'm doing. We're going to look at API latency next. What's that?
Happy little graphs.
Happy little charts. Yes. Happy
exactly.
little charts. We're going to, go with my preference here. Going back to metrics here, this is an interesting one. So we've got HTTP server request second count. This is one of the auto-configured metrics for you in Spring Boot. It's going to automatically instrument your WebMVC or WebFlux endpoints and record all sorts of information about their latencies and so forth. And you'll see we record a number of different things. We'll record the exception name if an exception occurred. We'll record the instance ID here, the job that comes from Prometheus. We'll record the HTTP method, the status, the URI, et cetera. In this case, let's just look at the person's endpoint. So we're just going to narrow it down on that one. And I kind of mentioned before, this is the total number of requests that's been executed against that endpoint. But it's never very useful to look at this total number because it grows with both the frequency at which the API endpoint is exercised, but also the amount of time the application has been alive. So in almost every case, we want to look at the rate instead. And we see that this API endpoint is working at approximately 270, 280 requests per second right now. And so we can take this and we can do a little bit more. We're gonna look at some like we did before. And of course, this is the average latency. Let's go over to the axes like we did before and say this is a unit of time. And I mentioned before Prometheus is base unit of seconds, so we're going to select seconds here. And now Grafana has done a great job of presenting the scale to us in a way that's easy to read. So we can see 10, 11 milliseconds per endpoint. Honestly, this is where a lot of folks have stopped. And for a long time, people have looked at average latency on applications, and we don't think that's really wise. There's average latency only represents what the best 50% of your users experienced when they interacted with your API, and the other 50% can be substantially worse. We'll look at a few of these. Let's look at say like the 95th percentile. And we'll do something similar here. We'll look at HTTP server request second bucket, which is, again, this is something that's peculiar to Prometheus, but Micrometer knows that Prometheus has this histogram quantile function, which allows us to generate percentile information. What did I mess up here? Oh, yes. I messed up a lot of things. And so it knows how to format these buckets in a way that that Prometheus knows how to understand. Okay, let's see here. Rate seconds bucket. URI persons 1 minute. Maybe we should. I may be getting the order of the parameters wrong. Nope. Oh. Okay, so that's closer. Maybe this first. I'm just not remembering right. There we go. So you'll see that the average latency was, 10 or 11 milliseconds. The 99th percentile, so the latency that that 99% of my users experience was something like 15 milliseconds. Also the load test finished, so we're going to kick it off again. And you think, and honestly, so, a lot of people start with average, and then those that are feeling a little better about themselves introduce things like percentiles like this, and think, well, 99%, right? That's really what users are experiencing. But even this is surprisingly untrue. If you take a 1% chance, just think about that narrow slice of users in that 1% at the top, and you take that 1% and you multiply that times 100 chances, that's a 53.4% chance that one of those things is going to land in that top 1%. So the law of large numbers really adds up quick here. And if you think about your interaction with an application as a whole, say it's a suite of microservices, where you're submitting a request to a gateway, but that request is ping-ponging around down a series of microservices. That can be a lot of individual APIs that are exercised in the satisfaction of that request. For example, in a user session with 5-page views that load just 40 resources per page, the chances of not seeing something worse than the 95th percentile shrinks to just 0.003%. It's crazy how quickly that happens. We could go on, but so Micrometer has added an additional thing here. We know that that max is really important to look at, and see how dramatic that is. The max latency on an individual call was actually something more like 11 seconds. We had a nasty GC in there somewhere that caused us to jump up to that point. It just so dwarfs the average and the 90th. Look at the gap between the 99th percentile and the max. It's really nuts. We're going to hide this one for now because it's really destroying our picture. Just like we did before, we can take this format and we can say, I just want to view it as URI and status like this, and see, and I'll say that this is the average. And I get a nice pretty legend here, just like this. Or I could do the same thing down here, URI status 0.99, and get a nice little representation there. So that's latency. When we think about just max, this is something that sets Micrometer apart. The Prometheus simple client does not ship with a notion of how to ship or to publish a decaying max. So that's something that we know is important, and that's something that we learned from Netflix's experience. Max is embedded into the spectator metrics collector, and it's expected by Atlas, but it's not something that the Prometheus folks have adopted yet or understood yet. And it's not something that the Datadog folks have understood yet with their instrumentation. And so Micrometer is going to drop that important statistic down on every monitoring system that it supports, because we know that's important. But again, that's one of the things that really sets it apart. All right, so we've looked at a few metrics over here. Let's go over to a little bit more in the code. Back to where I like to live. There's, in addition to this, we already mentioned that you could create, say, a component, and we could use Spring's constructor injection mechanism to automatically inject this meter registry into the component. To make this sound public. And then we could use that registry, so we could start recording metrics and so forth in here. And that's great if you're in a Spring environment. This is the recommended way to do that if you want to collect custom metrics. But if you say you're working in a low-level library, a good example was Reactor. Reactor is wanting to add Micrometer support to Reactor Core. Well, they've got types like Flux that aren't going to be able to be dependency injected. So in that case, you can create a counter with this global composite. So there's a global static registry as well, and so you can interact with something like this. And this is kind of where the SLF4J for metrics thing kind of originated. This looks a lot like, you know, logger equals logger factory dot, you know. So they're similar in that sense. They're similar in the sense that it's a concern that, you know, you want the components that you want it to log, but you don't necessarily want to surface the fact that it's logging through and leak it through its public API. And so we allow you to do that, especially for your core libraries and things where you can't do dependency injection. And this top-level global composite is special. It's a composite registry, so if there's nothing that's ever added to that composite registry, any increments that happen to this counter just do nothing. It's just no ops. So I can still use this in my code, even though there's no metrics implementation on the class path, that nothing's happening, you know, that I don't want any. It's just a really, you know, efficient short circuit to a no-op operation when you do something like this. But Spring Boot is going to take the registries that it auto-configures, and it's going to add them to the global composite. So when you have libraries on your class path that have done something like this, all of their metrics are going to be included in the output from Spring Boot, regardless of whether, without there being a wiring that needs to happen. So that's cool. That's something more about that. But here's another thing that really sets Micrometer apart. We expect that, you know, that really metrics are as important, or, you know, because I'm biased, a little more important than logging. It really should exist in a lot of places in the code. It's really a concern you need to take to heart. But that can really add up. If you have a lot of libraries in your class path, you're going to be emitting a lot of metrics that you may not be using. You may use them in one context and not another. So there's a concept called a meter filter in Micrometer that, like, we can blacklist JVM metrics, for example. And we can, whoops. So we can say deny name starts with JVM. And so anywhere in your code that where something tries to represent or to create a JVM metric, it just short circuits no ops the thing. And so it won't ever be exported. That's a way to do that. There's a lot of different things you can do with meter filters. You can get really more sophisticated by saying deny anything about the ID, like if it has a particular tag I don't like, if it, you know, different things like that. You can accept them to force them to be on. This is the deny and accept side is very similar to logback filtering mechanism. You can say the maximum allowable metrics across my whole thing is, say, 10,000, and maybe this will protect your application from, you know, some rogue library in your class path just adding a ton of metrics that would potentially have an influence on your heap. So you can do that. You can say maximum allowable tags. One thing I guess we didn't mention earlier is when you add tags, so say I had that HTTP server request tag or metric, I don't want to add things like user ID or you know, incoming IP, you know, because this number is going to be huge. You know, it's going to grow. There's going to be a lot of distinct values for that, and each one of those get represented as a row in the database, the time series database. So, you know, it could really, you know, blow up the database on the back end. The metrics that we record automatically for you are carefully selected to make sure they have low cardinality. It's like HTTP method can only be get, post, put, delete. You know, there's a fixed number of those. Similarly, when we tag URI, notice, I didn't do person John. I did instead I did person name. I always represent it as the parameterized name. So you get an idea of how many times that API was exercised without blowing up the monitoring system on the back end. But just to be sure, I mean, you may include a library at some point that intended to have a low cardinality tag and didn't, and so you're able to select here, constrain the number of maximum allowable tags on it. So that's full filters. There's another mechanism we have called a meter registry customizer. And here we can add things like common tags. So a common tag may be like my application. It could be, depending on the context, it could be, if I'm running in AWS, it could be the region and the availability zone. It could be any number of things. And when you add a common tag like this, that gets applied to every metric that's reported across the whole application. So if I was interacting with a type like Flux down here that just defined a counter like this, these common tags up here, app, my app, US, region, and so forth, would be added to this counter before it's published. So that's great. That allows a lot of customization there for you. If you have a composite scenario where you have, say, CloudWatch and Prometheus at the same time, you can conditionalize this to just a particular implementation. So, it's very common in CloudWatch, for example. I don't have that on the CloudPath, but CloudWatch is really expensive. So I may want to just deny everything except for a small set of metrics that I want to ship to CloudWatch and allow the rest of them to go through to Prometheus. So difference there. And then finally, there's a meter binder which allows you to create an encapsulation of a set of metrics. Any meter binder that's on the class path gets wired automatically. And this interface, again, there's not much to it. It's just an opportunity for you to say registry.counter 1 and registry.counter 2, and just add a bunch of different metrics all at once and encapsulate that in a named type. And there's a number of those that are provided out of the box. So like JVM GC metrics is a meter binder that you saw earlier, and we go through and add information about GC for you. So that's that. Over on the property-based side, Spring Boot also enables you to do simple things like deny metrics on the basis right here. So you can say HTTP server request is false. Like, I don't want to ship this metric, and you can do that in a property-driven way as well. We also allow you to configure things like percentiles and SLAs and so forth on timers right here in the configuration, so that if somewhere I've just created a timer, I've just created a simple timer like this, my.timer, and I've registered it with the global composite, for example. And I didn't define in here, like I could select to add SLAs right here, or I could choose to go over to the application properties and add those SLAs in a declarative way in your properties. So there's a lot of options, a lot of choices. We're going to have a lot more information coming out, another Spring blog coming out about all the gory details of the options available to you, especially for timers. So look for that. And with that, I just want to make one note about the future. The reason we spent 2017 on this, or I spent 2017 on this, is because we're imagining a future where Spring the Spring portfolio expands to things like automated canary analysis with Netflix, Google's Kayenta platform. And we want to do things like server outlier detection and intrusion detection and predictive auto-scaling, and things like that. And these kind of higher order operations or site reliability functions all rely on the basic premise that you have key performance indicator metrics on your application, so that when I'm assessing a canary server against an original server, I can determine whether it's good or bad. I'm looking at some key performance indicator there. So this is what we're moving forward with in 2018 is trying to build on this foundation we provided with Micrometer to enable you to do much more sophisticated operations engineering in the future. And with that, I think I'm going to open it up for questions. What have you got?
Sorry, John, just getting off mute there. Yeah, so nothing at the moment, but I think one thing I know, or I think a lot of our listeners would be interested to hear more about is, could you speculate a little bit on what sort of the future holds for running Micrometer apps on Micrometer boot-enabled Micrometer apps on Cloud Foundry? Could you talk a little bit about sort of what you might see coming either now or in the future? I think that would be of interest to a lot of people.
Sure, yeah. I think for Cloud Foundry, PCF Cloud Foundry has a PCF metric component to it that they're continually working on and adding more dimensional capability to now. There's also an excellent washable Prometheus available out there. We could put that in the resources at the end, but I think it's a good solution on Cloud Foundry. And there's a third-party tool called Prometheus that when compared with Bosch Prometheus is really effective. I mentioned that Prometheus has this unique characteristic that it pulls metrics from instances. And that's a little harder to do in Cloud Foundry because to pull a particular instance, you have to add a header and so forth. And so Prometheus is kind of a component that sits between your Prometheus and the rest of your Cloud Foundry foundation, and it knows how to pull each of the individual instances in Cloud Foundry. So I think that's probably a fantastic option for a lot of people today.
Cool, thanks. Before we continue, folks, this would be a great time to check out not only the attachments and links section for John's carefully prepared GitHub repo from today's demonstration, but if you would also take a moment to maybe rate the webinar and let us know what you'd like to hear about in the future. And there's also a short poll that John was kind of hoping we could get your feedback on. We'd love to know a little bit more about some of the different monitoring platforms that we could integrate with in the future. Could you take a moment and do that now? That would be awesome. Also, just want to make people aware.
And to be clear there, Peter, all the answers on that list are monitoring systems that Micrometer already supports. But if there's anybody in the audience that would like a version of the dashboard that we've shown today with that uses the query language of that particular monitoring system, then vote for which one you want, and we'll provide a take-home for you on that.
Ooh, cool. No, that's great. All right. And John is going to be at Spring One Platform in September 2018 in Washington, D.C. And if there should be a banner going across your screen right now with a link where you can get $200 off before July 31st if you want to register now. So John is going to be there showing more Micrometer updates, as well as obviously we're going to have an amazing lineup of Spring, Cloud Foundry, DevOps, business speakers on transformation, serverless, microservices, and all kinds of stuff. So in addition to core Spring tracks, data databases, all that kind of stuff. So especially if you're on the East Coast and it's easy to get there, this would it's an amazing conference.
Washington, D.C.
Yeah, Washington, D.C. We're going to be in just outside of the city, so it should be easy to get to via airport. So that's going to be an amazing event, and I think we're almost looking at somewhere between 3,000 and 4,000 attendees this year. So certainly growing dramatically in size, but yet we're not kind of at a impersonal scale of event. So you still get a lot of face time with people. It's just an amazing event. Also, if you're looking to get a hold of bits for Micrometer, as John mentioned, this is the default metrics implementation in Spring Boot 2.0. For standalone downloads, is that a thing, John? Do they need to go to the website, or is it all just Maven and Gradle?
Yeah, I mean, it's followed with Maven and Gradle. The binaries are available in Maven Central and JCenter for you to get there. Yeah. Fantastic.
And if for some reason you are stuck on a military network or a closed network, behind 20 layers of proxy servers, and you absolutely need an HTTP download, you can get that from our Artifactory repo.spring.io nightly build server. We don't necessarily make it super easy to find, but it is available. Just thanks for taking the time to give us some feedback and vote on the poll, and also just let us know what you'd like to hear about in the future. Sounds like serverless is definitely of interest for at least 4 of you. So we'll be looking at more. The one question did come in, John, while we were chatting. Will Elastic be supported?
Yes, I should have mentioned the Elastic is actually supported in the 1.1.0 snapshot line already. We'll land support for Elastic in Spring Boot and Spring Boot 2.1 early this fall. But yeah, that implementation was contributed by the community. We're also adding more. We're adding Dynatrace, I think, is already done now. Microsoft is working on the App Insights for their Azure platform integrations. I can't remember them all, but I think Zabbix is on the list. There's a bunch more coming as people express interest in them.
Fantastic. All right, thank you. So yeah, I think one of the other questions that, John, that I know I had when I first heard about Micrometer is sort of, a lot of these companies like the, Dynatrace, New Relic, App Dynamics, these folks.
Yeah.
Talk to me about, tell us just for a moment a little bit about where does Micrometer sit in sort of that spectrum of tools? Like, if that's something,
that's a great question, Peter. Yeah, it's, frankly, I see them as walking hand in hand. So if you have, for example, a Dynatrace, they're going to provide a Java agent you can attach to your application, and it's going to come up with some white box metrics for you or black box metrics for you. It's going to collect a certain number of things, and that's great. I think you can use those. You can use the pre-canned visualizations that those APM vendors have provided for you, and you can use those to great effect. We just had a scenario with a customer earlier this week where they were using a particular APM vendor that the agents know how to reach down into a Jersey endpoint embedded into a Tomcat application and instrument those requests. And it was critical that we had that information. So, we were able to just, leverage Micrometer to expose HTTP server requests to Jersey endpoints, and then we had a lot more visibility. So I think they go hand in hand. There's only ever so much you're going to be able to do with black box metrics. And, eventually KPIs on applications are going to be defined by the user as well. They kind of work together in that sense.
Understood. And, from my understanding, I think a lot of those monitoring vendors, the vendors that we were just talking about, they're sort of working up higher in the stack, looking at machine learning and automated signal analysis and areas like that.
Right.
So,
that's right. And giving you great charts and visualizations. Absolutely. Good alerting functionality and things like that. Yeah, and that's great. That should be their focus.
Yep, exactly. So hopefully, folks, that kind of puts things in context for you and gives you some sense of sort of where Micrometer kind of fits. And I guess, if there are no more questions, we can start to wrap it up here. I think maybe the last one that might be of interest would be, just maybe a quick comparison to what were we using before? Was it Drop Wizard metrics? I think was something a lot of people were using along with Spring Boot. And maybe just a quick word or two about, I think people now, having seen your demonstration, I think they kind of understand that there's obviously a big difference between those. But if you could just comment on that a little bit more above and beyond, the sort of SLF4J, you have this one sort of API and abstraction that you can hook in, and you get some portability, to your point. But what are some of the other differences that you would characterize as sort of versus something like Drop Wizard that a lot of our listeners are familiar with?
Yeah, I think, Drop Wizard 4, of course, was hierarchical. And so those metrics are not going to look right. You're not going to be able to do the dimensional exploration we were showing today in the dashboards with dimensional or with hierarchical metrics like that. And that's okay. In Drop Wizard 5, they've moved to a dimensional scheme. And so it's not going to be, you're not going to be able to just take Drop Wizard 4 code and, upgrade the version and maybe integrate it and be good to go. It's going to be a complete rewrite anyway of your metrics instrumentation, because the API just looks different when you're collecting dimensionally versus hierarchically. So yeah, we kind of knew that was the case. Some of the big differentiators I don't see in another dimensional collector out there right now are naming convention normalization, which isn't just a toy, it's super important. The base unit of time normalization, filtering, the ability to hang distribution statistics on metrics at the last minute, and then just the recognition that, and this is how we differentiate, say, from open census. There's a recognition in Micrometer that the exposition format is fundamental between backends. So, there's not a single proto that I can define for a timer that says I'm going to shift count sum, average, max, standard deviation, because on Atlas doesn't want to see average. It doesn't want to see deviation. Stackdriver requires it. Prometheus has a particular cumulative histogram format. Atlas has a non-cumulative rate-based histogram format. So, there's just that recognition that there's fundamental differences in monitoring systems that we need to treat that way.
Totally understood. All right, that's awesome, John. Thank you so much. I think that really helps kind of put things in context for everyone. Yeah. So, folks, feel free to share the replay with people. It'll be available within within an hour or two, I think, of close the webinar on the Bright Talk channel. It's the same URL that you use to register for the event, and you can share that with your colleagues, as well as the GitHub repo if you're looking to kind of explore and introduce other people to this technology. Again, we really encourage you to have a look at Spring One platform as that's coming up in September. There's going to be a lot of great content there, and right near the DC airport area. So, John, thank you very much. Please have a look at, follow John on Twitter, and his Twitter handle is right up front here, John_K_Schneider on Twitter. And then, if you'd like to, we're looking forward to seeing you on an upcoming spring webinar. We actually have one tomorrow with Ryan Baxter on Spring Cloud Gateway as well. And then next up in next month, we're also going to be looking at Spring Cloud Stream 2.0 or 2.x, with Oleg, the new project lead there. So looking forward to having you back on a future webinar. John, thank you so much for your time and answering some questions.
Yeah, thank you, everybody, for
preparing all this code. Looking forward to meeting you up with you at Spring One. And anything you want to say before we call it?
No, just thank you, everyone, for attending. And, hit us up on slack.micrometer.io if you have any questions. I'm there all the time, or somebody is.
Oh, perfect. Slack.micrometer.io. Awesome. Okay. Very cool.
Yeah.
All right, John. Thanks a lot. And have a wonderful day, everyone. Take care.
Bye.